So in this video, we are talking about compass and true bearings, another topic that we have covered before, but it is in the Year 12 Standard 2 course as its own thing, so it's important that we go over it one more time. Now, bearings deal with directions, right? It's essentially some kind of angle position of one point relative to another. Now, we measure bearings always from north. So we imagine if I say a point's here, and a point's down here, we want to find the bearing of this point from this point. We think of it in terms of the angular position from north over to the other point. So we draw kind of like an imaginary line and a north sort of pointing direction, and the angle we're looking for is just this one here. Now, wherever we are situated, that changes the angle. So if we had, for example, here, say the point was here instead, we're always going to measure from the perspective of north. So this time, it's going to be a reflex angle here, right? So there's a couple of ways we can work through this, and there's sort of a couple of types of bearings that we're going to talk about. We have what we call compass bearings. So these, we talk about a direction given by stating the angle either side of north or south. So we give whether it's closer to north or south. So that depends on the quadrants, right? So if it's somewhere up here in this example, this one here, it's closer to north than it is to south. So it's going to be between north and east. Here it's going to be between south and east, between south and west, between north and west. And we always put north or south first. So this angle that we've been given in the example, south 60 degrees east, that means that from south, I am making an angle that's 60 degrees somewhere here, and it's in the southeasterly direction. So south, 60 degrees between south and east. We'll go through how these are going to look more explicitly, but we're just introducing you to the two different types of bearings. We also have what we call true bearings. Now, a true bearing is a direction given just by measuring the angle clockwise from north to the required direction. So the one that we gave at the start, where I gave you, for example, this point here and another point here, and I had north, this is an example of a true bearing. And some other textbooks call it like a 3-figure bearing. It's because we always write these as 3 digits. So 120 degrees, and then we put our degrees, and then T, which stands for true bearing. So we're going to go through a lot of these in these examples, but hopefully that gives you an idea of sort of how we can classify the two. Now here, this is saying in example 1, to find the true bearing of C from O. So the word from is really important. It's C from the perspective of O. So from O, we draw north, and then we measure the angle. Now you can see C is located here. So the angle we're looking at is C from O. So it's this angle that they've labeled for us over here. So the bearing of C from O is 210 degrees. And we're looking for a true bearing, so we write our T over here. It's 3 digits and then the T. Now in part B, they're saying D from O. Now, all of these little bits here make up 90 degrees. So north to east is 90 degrees. East to south is another 90 degrees. So it's 180 degrees here to here. So 180 degrees, south to west is another 90 degrees, 270, and we go 60 degrees extra. So the entire bearing we're looking for is this angle all the way to D. So we have our 90 degrees, our 90 degrees, our 90 degrees. So 90 plus 90 plus 90 gives you 270, plus 60 degrees gives you 330 degrees. So we are measuring always from north, and we just draw it all the way around until we hit that imaginary line that joins D to O here. Now, example 2, He's saying a plane is traveling on a true bearing of 30 degrees from A to B. So let's actually just draw a picture, because remember, the quality of our answer is only going to be as good as the picture we have drawn. So we have A, we're going to measure north from A, and it flies on a true bearing from A to B of 30 degrees. So we're looking for, now this is a 3-figure bearing, right? So that's why it's written 030. That just means 30 degrees, because 30 isn't a 3-digit number. So we put the 0 in front of it to make it 3 figures. So this is 30 degrees. And think about it. In our entire northeast, southwest, because the first part, A, is asking for our compass bearing. So we have north, east, south, west. The compass bearing of A to B, remember to write compass bearings, we have to start with north or south. Now this is clearly closer to north, so we write N, then we do 30 degrees, and then we write the E here. This is the compass bearing, not the true bearing, of A to B. Now, next part's where it gets a little bit trickier, okay? It's saying, what is the compass bearing from B to A? So A from B or B to A. Now, we're going from the perspective of B this time. So what we're going to be doing, just so this picture doesn't get too kind of muddled up with all of this, because it can get a bit overwhelming, especially with bearings. If I move this picture down, apologies, we need to consider from the perspective of north, not from A, but from B. Actually, let's keep that one. I'll tell you why in a moment. We're going to draw north from B. Now, I want you to think about this. Both of these are pointing in the direction of north. If the arrows are both going in the same direction, fully north, could we then say that these two lines are parallel? Well, yes, we could. North is always going to be parallel to north. East is always going to be parallel to east. This is if we're thinking in terms of a true north. So because these are parallel lines, that can tell us about certain angle relationships. Now, imagine if I extend this line down a little bit. These are parallel lines, and you can see that we have a Z shape happening here. This is similar to what we were dealing with in the angles of elevation and depression. We have an alternate angle here. So because these lines are parallel, we get a lot of angle relationships happening. So not only is that angle going to be 30, this angle is also going to be 30 degrees, which means the true bearing of B to A is this entire angle here, right? Because we're measuring from north and we're always going in the clockwise direction. So this angle all the way down here is a straight line. So that's going to be 180 plus the extra little 30 that happens here. So the true bearing of B to A is going to be 180 plus 30. That gives us 210. And we're going to write degrees T because it's a true bearing. Hope that part was okay. But this is how we can kind of work through these. It does get a little bit tricky because we're trying to visualize it. Now, when we change the perspective, we're looking from B now, then we need to draw north from B and then try to find the bearing from there. Now, this is getting a little bit muddled up, so I'm going to clean up the picture a little bit again. Let's fix this up just a bit. So just cleaning up. Now, let's leave it like this. Now, we're trying to find, we've got point B here. Now, we're looking now for the compass bearing of B to A. So imagine we have north, east, southwest, and then west in this direction. Now, we're trying to find the compass bearing. So this is, we have to write, first, we have to decide, is it first closer to north or south? Now we can see that this one, A, is in between south and west, right? So if this angle in here is 30, the position of A, if we rewrite 30 here, if we write a compass bearing, it's going to be south 30 degrees, then west. Because a compass bearing basically just tells us what the angle separation is in a direction between north to east, south to west, or north to west. So we're going to write S, 30 degrees, then west. This is how we can work through and change some of our true bearings to compass bearings as well. Now, last question before we wrap up, we have to draw a picture, okay? So it's saying a cyclist rides 15 kilometers on a bearing of 290 degrees. So I'm going to draw in my axes just to make this easy to work with. So I have north, east, south, west. And let's call this O. That's sort of our origin, our starting point. Now, the cyclist rides 15 kilometers on a bearing of 290 degrees. Now, remember, from here to here is 90 degrees, 180, 270. So 290 is going to be somewhere up here. So we're going to draw in our line for our diagram. 290 is going to be about here. Let's make this a straight line. Okay, so that means that this angle here, all the way around, apologies. This entire angle here is 290 degrees. Now, once we do this, we know that all the way up to west is 270. So that means the angle in here is going to be 20 degrees because we need this to answer these different questions, right? But we know that we have the cyclist's path, we have the horizontal, and we know that this angle, if it goes all the way to 290 and up to here's 270, this angle is going to be 20 degrees. So let me actually just redraw this as a right angle triangle. Let's see why I've done this in just a moment. Well, let's just label in what we know. The person rides 15 kilometers, so they've gone 15 kilometers. This side's 15. This angle is 20 degrees. And they've said how far north is the cyclist. So how far north is the cyclist from their starting point? So that is this part here. So that, in essence, is going to be my unknown side. And it is a right angle triangle. So let's think we've been given an angle. We have a side opposite it. And we have the hypotenuse. So for part A, we're going to say that because we have opposite and hypotenuse, this is going to be sine. So we're applying our right angle trigonometry to this question. So sine of 20 equals x over 15. So x equals to 15 sine 20, which equals to one decimal place. I'll just go straight into the answer. That's going to give you 5.1. And that's kilometers. Okay, part B, it's saying how far west is the cyclist. So this length here, how far west is the cyclist? We're looking for this guy here. So let's call that y. And this side y is the adjacent, okay? So when we have the adjacent and the hypotenuse, we're going to say that cos of 20 degrees equals to y over 15. So y equals to 15 cos 20. We put that in our calculator, 15 cos 20, and that gives us 14.1 kilometers. Okay, so we're almost at the end here, but we're just applying our right angle trigonometry to this bearings question. Now, this is saying, what is the true bearing of the cyclist's starting position from the cyclist's current position? So let's just reset this picture. Let's sort of make it less sort of overwhelming for us. Let's go back to our initial picture. Now, we have the person's final position and their starting position. Let's literally strip this back. We have O, that's the starting position, and this is their finished position. So let's call that F. It's the original and the final. Now, we have to be careful with the wording. It's the bearing of the cyclist starting from the finishing. So, because it's from the perspective of the finish, we have to draw a north from F. So, this is the north. Now, remember, we know that this entire angle is 290 degrees. Okay, now if we know that that's 290 degrees, remember the angle we want to find at the end of the day is this one. That's the bearing of O from F. So from north of F, it's the angle it makes with that line joining F and O. Now, if it's gone 290 degrees here, we know a whole revolution is 360. So this extra angle here will be 70. Because that's just the difference between 360 and 290. So this guy's going to be 70 degrees. And because these are parallel, because remember north is always parallel to north, think about what shape I have here. I've made a C shape. These two angles are what we call co-interior angles, right? Apologies. This unknown angle and 70 are co-interior angles, meaning they add up to 180 degrees. So to find this unknown angle, let's call it X. Our angle X equals 180 minus 70 degrees. Because they are co-interior angles. The angles inside the two parallel lines add up to 180 degrees. So the bearing of the starting position from the current position, from the final position, is 180 minus 70, which gives us 110 degrees. So this is how we can now start to apply our right angle trigonometry to our bearings questions. And it all starts with drawing a good picture. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.